Welcome to another episode of Econauts. My name is Simon and I'm here with my brother Ben, the Rocket Man. Um,
Hey.
we are talking about science, space, and economy, and our topic today is orbits. First question: what is an orbit?
Well, an orbit is a relative motion around our planet, around any planet, but obviously we want to stick to Earth today. So any relative motion around our planet is an orbit, and the orbit is defined as something which doesn't let the thing which is orbiting falling onto Earth. So it has enough speed to fall over the horizon.
Okay. So then
I think
what?
that's a good explanation.
Yes. So what kind of orbits do we have available?
There are many orbits, but I think let's just focus on the ones which have a commercial um, relevance to us.
Yeah.
So we have and I will also give examples later what's going on in each of those orbits. So we have the low Earth orbit, which is between 160 and 2000 kilometers. We have the medium Earth orbit, or MEO, which is between 2000 and 35,000 kilometers, 36,000 kilometers. Or my TH is sounding very ridiculous today. Thank you very much. We have the geostationary orbit, which is a circular orbit, and it's located approximately 36,000 kilometers in height. And then we have other orbits such as the highly elliptical orbit. We have a sun synchronous orbit and others as well. There's many orbits, and I would like to focus today on low Earth orbit,
All right.
geostationary orbit, and the sun synchronous orbit.
So what is the significance for those orbits?
Yes. So let's start with the geosynchronous orbit. I think they are quite significant. Geosynchronous orbit means it's an orbit where the speed that the object circles the Earth matches the rotational speed, which means looking from any spot from Earth, if you look at a geosynchronous orbit above you, or an object in geosynchronous orbit above you, it is relatively speaking not moving, which is like means it's always at the same location. If you look straight up and let's say there is one, that's where it will be all the time. And the significance for those orbits is for communication, for TV, for example, or satellite TV. That's why your satellite dish on the roof is facing one direction. Then when you want to set it up, you have to point it at that satellite. And now imagine that that satellite would move all the time. That would mean that every of these satellite dishes would have to be equipped with a tracking station.
Right.
That would make them very expensive. The low Earth orbit, which is the lowest to reach, has significance for example, for the space station. The ISS is in that orbit. Communication satellites are there as well. Starlink, for example, Earth observation satellites and remote sensing satellites are in low Earth orbit as well. The sun synchronous orbit is a special type of low Earth orbit, meaning that so it's usually a polar orbit or near polar orbit, and it follows the sun, meaning that at a certain time of the day you will find the satellite at a certain location, which means you can, for example, you could use that for remote sensing if you want to observe a certain spot every day at the same time. And then, I think of course, the high elliptical orbit is important as well. The medium Earth orbit is important as well because that's where the GNSS satellites are located, such as GPS and Galileo.
Oh yeah, I just wanted to ask. What kind of satellites?
Yeah.
GPS and?
And Galileo. Galileo is the European version. There's also a Chinese version of GPS. GNSS stands for Global Navigation Satellite Systems.
And they're in what? GPS, for example. In which orbit? Sorry, I was.
In the medium Earth orbit.
And why is that? To have like a better radius to scan?
the so the distance is perfect so that you can set up a constellation
Yeah.
so that any device always has access to a minimum of 3 of those satellites, and they all of these satellites are equipped with a precision timing device, usually with rubidium, and by taking the time differences from those satellites, which are usually you need 4 actually, which are synchronized, you can then deduct the exact location on Earth up to millimeter precision.
All right. Um, I know. I remember that we talked about polar orbit and what was the other one? Equational
Sun
orbit,
synchronous and Leo equatorial. Yeah.
equatorial orbit, and polar orbit. So so I can imagine, and that's coming from knowing that if you have like air traffic, you have like different kind of corridors for different kind of planes, so that they are not crashing, right? And obviously, you have also like at each airport, you have like people making sure that planes are not crashing in each other. This is of course a little bit more complicated when things are in orbit. So I can imagine that a very similar rule also applies for having those satellites in orbit around Earth. And you already mentioned that there's a huge margin in each orbit. Can I assume that so that they are not, crashing in each other, that they are basically in different layers flying around?
Well, I think it's a very interesting question and also very important. So every object in orbit, in any of those orbits, is tracked as good as possible. So we have debris, which obviously we cannot really control, but we can predict where it will be. And we have many objects, such as satellites, which we can actively correct and remotely operate. And we usually know for those weeks in advance where they will be, and therefore we can adjust their orbits. And also, each of those objects, especially the ones which are controllable, are attached to a ground station. So they are permanently in communication with a ground station which can adjust for any problem.
Yeah.
Yes. But yeah, it's the topic is important because with more and more objects in, let's focus for this talk on Leo with Starlink, for example. There's more and more constellations planned or already being or positioned in low Earth orbit. Therefore, the orbit gets more and more full.
Yeah.
There's still lots of space in between every object, but if objects are coming in close distance, which is a couple of kilometers, they will still miss each other. But that's already, from our perspective, it's already very close, and we want to avoid that. All these objects, they are flying with many kilometers per second in that orbit. So if they crash into each other, even a small object, a millimeter object, will rip a golf ball sized hole into another object. So there's lots of kinetic energy involved. So we want to avoid any collision.
Of course, yeah. Especially, we are not talking about they're not even if it looks like that they move very slowly, especially those objects that we can follow with our position on Earth. It may look like that they are not moving at all, but I mean we're talking about like very high speeds up there, right? So how
Exactly, yeah.
so how quickly are they moving around? So the ISS, if we take that as an example, so how quickly, what is the speed of the ISS basically?
The ISS basically flies with, from the top of my head, I think it's 7 to 8 kilometer per second in low Earth orbit.
8 kilometers per second.
Yeah,
That's
I think it's 7.5 or something in that. I have to look it up to be fair, but it's something around that.
that's not like a that's not what a car can
No,
actually do.
no, that's a bit faster.
That's a bit faster.
Um,
Um,
yeah. So imagine it, even if there's something standing in the way, I mean,
Yeah.
everything is moving there, but
Yeah.
obviously 7 kilometer per second, a small object has a large
Impact.
kinetic energy.
Yeah.
Yeah. So also I think that's important. You asked how if there's a regulation. The regulations, they are very strict actually. So everything which goes into orbit needs to follow very, very strict guidelines. And that needs to be able to deorbit, for example. I think since this year the regulations state that everything in low Earth orbit has to deorbit every 5 years. So meaning for Starlink, let's say, Starlink currently has around 2,000 objects in low Earth orbit. They want 12,000 satellites in low Earth orbit to make everything running smoothly. They plan to do 44,000 in low Earth orbit. If you now also imagine that they have to deorbit every 5 years, it becomes quite busy up there. So up and down, and yeah.
I know that we talked about that off camera before, and you were saying that you may not even know the answer to that. But so there is a reason why the ISS is in low Earth orbit, right?
Yeah, because it's easier to reach.
It's
if
easier
you
to
would
reach.
be farther away, obviously it would be more expensive and would take longer. So
Right.
now, because it's so close, we can actually reach it quite quickly with a Dragon, or with SpaceX,
If we would build another
an astronaut
space
thing.
station, would it make sense to use a different orbit, maybe higher?
The space stations for Earth are planned more for low Earth orbit.
Yeah.
But there are, so the NASA Artemis program, for example, is planning Gateway, which is a space station orbiting the moon. So
Oh,
that's obviously further away.
yeah, that's a little bit further away. Yeah, you cannot reach that in a week.
No, that doesn't take that long to get to the moon.
It takes about a week, right?
Well, again, I don't have the answer
you
from
can
the top of my
you
head.
can look that
I will
up.
Google it quickly.
Yeah, Google that quickly.
How long?
How long does it take to the moon?
So I will. That's an interesting. 3 days.
3 days.
About 3 days.
3 days.
Yeah.
See, you can go back and go to the moon and back in a week, no problem.
In a week.
In a week.
Yeah.
Fantastic. All right, so so now I embarrassed you enough
Yes.
for one day. Okay, so
Thank you very much.
you're welcome. Okay, so this is it for our episode today. Thank you for tuning in. I hope you had some fun. We certainly had.
Yes.
Okay, leave a like, and if you like to see more, don't forget to subscribe, and we would love to have some comments as well. All right, have a good day. Goodbye.
Have a good day. Bye.
Bye bye.